Sodium carbonate, not to be confused with sodium bicarbonate, a similar compound. Sodium carbonate, not 2CO3, also known as washing soda, soda ash and soda crystals, is the inorganic compound with the formula Na2CO3 and its various hydrates. All forms are white, water-soluble salts. All forms have a strongly alkaline taste and give moderately alkaline solutions in water. Historically, it was extracted from the ashes of plants growing in sodium-rich soils. Because the ashes of these sodium-rich plants were noticeably different from ashes of wood, once used to produce potash, sodium carbonate became known as soda ash. 12. It is produced in large quantities from sodium chloride and limestone by the Solvay process. Sodium carbonate. Names IUPAC name sodium carbonate, other names soda ash, washing soda, soda crystals. Identifiers cast number 3D model, J small, interactive image chibi Chem spider.
Hecha Infocard 100.007.127.
EC number 207-838, AD number E500, I, acidity regulators.
Pub Shine CID 10340.
RTECS number VZ4 Uni.
Inchi.
Inchy rovná se 1 lomítko na chco třetí 2 na C2 pomlčka 1, 3, 4, H, H2, 2,3, 4, Q, 2 plus 1 lomítko P2.
Key, Bilp Swiswiknuk one Bap smiles.
N mais, O, C, O, igual a O.
Properties chemical formula.
N2CO3.
Molar mass 105.9888 g mol. Anhydrous, 286.1416 g mol. Decahydrate, appearance white solid. Hygroscopic odor odorless, density 2.54 gcm3, 25 degrees Celsius. Anhydrous, 1.92 gcm3, 856 degrees Celsius, 2.25 gcm3. Monohydrate, 1.51 gcm3. Heptahydrate, 1.46 gcm3. Decahydrate, 2. Melting point 851 degrees Celsius, 1564 degrees Fahrenheit. 1124 K. Anhydrous, 100 degrees Celsius, 212 degrees Fahrenheit. 373 K. Decomposes, monohydrate, 33.5 degrees Celsius, 92.3 degrees Fahrenheit. 306.6 K. Decomposes, heptahydrate, 34 degrees Celsius, 93 degrees Fahrenheit. 307 K. Decahydrate, 2, 6, solubility in water anhydrous, G/100 ml. 7, 0 degrees Celsius, 16.4, 15 degrees Celsius, 34.07, 27.8 degrees Celsius, 48.69, 34.8 degrees Celsius, 48.1, 41.9 degrees Celsius, 45.62, 60 degrees Celsius, 43.6, 100 degrees Celsius. 3. Solubility soluble in alkalis. 3. Glycerol slightly soluble in alcohol and soluble in CS2, acetone, alkyl acetates, alcohol, benzonatriol, liquid ammonia. 4. Solubility in glycerin 98.3 g/100 g, 155 degrees Celsius. 4. Solubility in ethanediol 3.46 g/100 g, 20 degrees Celsius. 5. Solubility in dimethylformamide 0.5 g/kg. Basicity, pKb, 3.67. Magnetic susceptibility,
Χ, πλην 4, 1, 10 έως 5.
cm3/mol2. Refractive index, Nd, 1.485. Anhydrous, 1.420. Monohydrate, 6, 1.405. Decahydrate, viscosity 3.4 cp, 887 degrees Celsius. 5. Structure crystal structure monoclinic.
Γ,
Form.
Β,
Form.
Δ.
Form. Anhydrous, 7. Orthorhombic. Monohydrate, heptahydrate, 1, 8. Space group C2/M. Number 12.
Γ,
Form. Anhydrous, 170 K, C2/M. Number 12.
Β.
Form. Anhydrous, 628 K.
P21/N, no 14.
Δ.
Form. Anhydrous, 110 K, 7, PCA 21. Number 29. Monohydrate, 1, Ka. Number 61. Heptahydrate, 8, point group 2/M.
Γ.
Form.
Β.
Form.
Δ.
Form. Anhydrous, 7, MM2. Monohydrate, 1, 2/M 2/M 2/M. Heptahydrate, 8, lattice constant.
A er lik med 8920, 7, og B er lik med 5245, 5, og C er lik med 6050, 5, og Γ.
Form. Anhydrous, 295 K, 7.
Α ίσον 90, Β ίσον 101, 35, 8, Γ ίσον 90.
Coordination geometry octahedral. Na plus. Anhydrous. Thermochemistry heat capacity. C. 112.3 J mol. K2. STD molar entropy. So 298. 135 J mol. K2. STD enthalpy of formation. Fo 298. Minus 1130.7.
Kjolmol, 2, 5.
집즈 프리 에너지 델타 FG도.
Minus 1044,4 kmol, 2.
Hazards. Main hazards. Irritant safety data sheet. MSDS GHS pictograms. 9. GHS signal word warning. GHS hazard statements. H319. 9. GHS precautionary statements. P305 plus 351 plus 338. 9. NFPA 704. 11. 010 lethal dose or concentration. LD. LC. LD50. Median dose. 4090 mg/kg. Rat. Oral. 10. Related compounds. Other anions. Sodium bicarbonate. Other cations. Lithium carbonate. Potassium carbonate. Rubidium carbonate. Cesium carbonate. Related compounds. Sodium sesquicarbonate. Sodium percarbonate except where otherwise noted. Data are given for materials in their standard state at 25 degrees Celsius, 77 degrees Fahrenheit, 100 kPa. Verify. What is? Infobox references contents. Hydrates applications. Main applications. Glass manufacture, water softening, food additive and cooking. Inexpensive. Weak base. Miscellaneous. Physical properties. Occurrences. Natural mineral production. Mining. Barilla and kelp. Leblanc process. Solvay process. House process. See also references. Further reading. External links. Hydrates. Sodium carbonate is obtained as 3 different hydrates and as the anhydrous salt. Sodium carbonate. Decahydrate. Natron. Na2CO3. 10H2O, which readily effloresces to form the monohydrate sodium carbonate. Heptahydrate, not known in mineral form. Na2CO3. 7H2O. Sodium carbonate. Monohydrate. Thermonatrite. Na2CO3. H2O. Also known as crystal carbonate. Anhydrous sodium carbonate, also known as calcined soda, is formed by heating the hydrates. It is also formed when sodium hydrogen carbonate is heated, calcined, for example in the final step of the Solvay process. The decahydrate is formed from water solutions crystallizing in the temperature range -2.1 to +320 C. The heptahydrate in the narrow range 32.0 to 35.4 C, and above this temperature the monohydrate forms. 13. In dry air the decahydrate and heptahydrate lose water to give the monohydrate. Other hydrates have been reported, for example with 2.5 units of water per sodium carbonate unit, pentahemihydrate. 14. Applications. Main applications. In terms of its largest applications, sodium carbonate is used in the manufacture of glass, paper, rayon, soaps, and detergents. 15. Glass manufacture. Sodium carbonate serves as a flux for silica, lowering the melting point of the mixture to something achievable without special materials. This soda glass is mildly water-soluble, so some calcium carbonate is added to the melt mixture to make the glass produced insoluble. Bottle and window glass, soda lime glass, is made by melting such mixtures of sodium carbonate, calcium carbonate, and silica sand, silicon dioxide, CO2. When these materials are heated, the carbonates release carbon dioxide. In this way, sodium carbonate is a source of sodium oxide. Soda-lime glass has been the most common form of glass for centuries. Water softening. Sodium carbonate is used to soften water by removing Mg2+ and Ca2+. These ions form insoluble solid precipitates upon treatment with carbonate ions. Ca2++ CO32 CaCO3 Sodium carbonate is an inexpensive and water-soluble source of carbonate ions. Food additive and cooking. Sodium carbonate is a food additive, E500, used as an acidity regulator, anti-caking agent, raising agent, and stabilizer. It is one of the components of kansu, a solution of alkaline salts used to give ramen noodles their characteristic flavor and texture. It is used in the production of snus to stabilize the pH of the final product. Sodium carbonate is used in the production of sherbet powder. The cooling and fizzing sensation results from the endothermic reaction between sodium carbonate and a weak acid, commonly citric acid, releasing carbon dioxide gas, which occurs when the sherbet is moistened by saliva. In China, it is used to replace lye water in the crust of traditional Cantonese mooncakes, and in many other Chinese steamed buns and noodles. In cooking, it is sometimes used in place of sodium hydroxide for lyeing, especially with German pretzels and lye rolls. These dishes are treated with a solution of an alkaline substance to change the pH of the surface of the food and improve browning. Inexpensive, weak base. Sodium carbonate is also used as a relatively strong base in various fields. As a common alkali, it is preferred in many chemical processes because it is cheaper than NaO and far safer to handle. Its mildness especially recommends its use in domestic applications. For example, it is used as a pH regulator to maintain stable alkaline conditions necessary for the action of the majority of photographic film developing agents. For example, it is a common additive in swimming pools and aquarium water to maintain a desired pH and carbonate hardness, KH. In dyeing with fiber-reactive dyes, sodium carbonate, often under a name such as soda ash fixative or soda ash activator, is used to ensure proper chemical bonding of the dye with cellulose, plant, fibers, typically before dyeing, for tie-dyes, mixed with the dye, for dye painting, or after dyeing, for immersion dyeing. Sodium bicarbonate, NaCO3, or baking soda, also a component in fire extinguishers, is often generated from sodium carbonate. Although NaCO3 is itself an intermediate product of the Solvay process, the heating needed to remove the ammonia that contaminates it decomposes some NaCO3, making it more economic to react finished Na2CO3 with CO2. Na2CO3 plus CO2 plus H2O.
12
In a related reaction, sodium carbonate is used to make sodium bisulfite, NaSO3, which is used for the sulfite method of separating lignin from cellulose. This reaction is exploited for removing sulfur dioxide from flue gases in power stations. Na2CO3 plus SO2 plus H2O.
NaCO3 plus NaCO3.
This application has become more common, especially where stations have to meet stringent emission controls. Sodium carbonate is used by the cotton industry to neutralize the sulfuric acid needed for acid delinting of fuzzy cottonseed. Miscellaneous. Sodium carbonate is used by the brick industry as a wetting agent to reduce the amount of water needed to extrude the clay. In casting, it is referred to as bonding agent and is used to allow wet alginate to adhere to gelled alginate. Sodium carbonate is used in toothpastes, where it acts as a foaming agent and an abrasive, and to temporarily increase mouth pH. Physical properties. The integral enthalpy of solution of sodium carbonate is minus 28.1 kJ/mol for a 10% WW aqueous solution. 16. The Mohs hardness of sodium carbonate monohydrate is 1.3. 6. Occurrences natural mineral. Sodium carbonate is soluble in water, and can occur naturally in arid regions, especially in mineral deposits. Evaporites, formed when seasonal lakes evaporate. Deposits of the mineral natron have been mined from dry lake bottoms in Egypt since ancient times. when natron was used in the preparation of mummies and in the early manufacture of glass. The anhydrous mineral form of sodium carbonate is quite rare and called natrite. Sodium carbonate also erupts from Aldoiniolange, Tanzania's unique volcano, and it is presumed to have erupted from other volcanoes in the past, but due to these minerals' instability at the Earth's surface, are likely to be eroded. All three mineralogical forms of sodium carbonate, as well as trona, trisodium hydrogen dicarbonate dihydrate, are also known from ultra-alkaline pegmatitic rocks that occur, for example, in the Kola Peninsula in Russia. Extraterrestrially, known sodium carbonate is rare. Deposits have been identified as the source of bright spots on Ceres, interior material that has been brought to the surface. 17. While there are carbonates on Mars, and these are expected to include sodium carbonate. 18. Deposits have yet to be confirmed. This absence is explained by some as being due to a global dominance of low pH in previously aqueous Martian soil. 19. Production. Mining. Trona, trisodium hydrogen dicarbonate dihydrate, Na3HCO3CO3, 2H2O, is mined in several areas of the U.S. and provides nearly all the domestic consumption of sodium carbonate. Large natural deposits found in 1938, such as the one near Green River, Wyoming, have made mining more economical than industrial production in North America. There are important reserves of trona in Turkey. 2 million tons of soda ash have been extracted from the reserves near Ankara. It is also mined from some alkaline lakes such as Lake Magadi in Kenya by dredging. Hot saline springs continuously replenish salt in the lake so that, provided the rate of dredging is no greater than the replenishment rate, the source is fully sustainable. Citation needed. Barilla and kelp. Several halophyte, salt-tolerant, plant species and seaweed species can be processed to yield an impure form of sodium carbonate, and these sources predominated in Europe and elsewhere until the early 19th century. The land plants, typically glassworts or saltworts, or the seaweed, typically fucus species, were harvested, dried, and burned. The ashes were then lixiviated, washed with water, to form an alkali solution. This solution was boiled dry to create the final product, which was termed soda ash. This very old name refers to the archetypal plant source for soda ash, which was the small annual shrub Salsala soda, Barilla plant. The sodium carbonate concentration in soda ash varied very widely, from 2-3% for the seaweed-derived form, kelp, to 30% for the best Barilla produced from saltwort plants in Spain. Plant and seaweed sources for soda ash, and also for the related alkali potash, became increasingly inadequate by the end of the 18th century. And the search for commercially viable routes to synthesizing soda ash from salt and other chemicals intensified. 20. Leblanc Process. Main article. Leblanc Process in 1792. The French chemist Nicolas Leblanc patented a process for producing sodium carbonate from salt, sulfuric acid, limestone, and coal. In the first step, sodium chloride is treated with sulfuric acid in the Mannheim process. This reaction produces sodium sulfate, salt cake, and hydrogen chloride. 2NaCl plus H2SO4.
Na 2 sobota 4. plus 2 HCl.
The salt cake and crushed limestone, calcium carbonate, was reduced by heating with coal. 15. This conversion entails two parts. First is the carbothermic reaction whereby the coal, a source of carbon, reduces the sulfate to sulfide. Na2SO4 plus 2C Na2S plus 2CO2. The second stage is the reaction to produce sodium carbonate and calcium sulfide. Na2S plus CaCO3.
Na2CO3 mais CaS.
This mixture is called black ash. The soda ash is extracted from the black ash with water. Evaporation of this extract yields solid sodium carbonate. This extraction process was termed lixiviation. The hydrochloric acid produced by the Leblanc process was a major source of air pollution, and the calcium sulfide byproduct also presented waste disposal issues. However, it remained the major production method for sodium carbonate until the late 1880s. 20. 21. Solvay process. Main article. Solvay process in 1861. The Belgian industrial chemist Solvay developed a method to convert sodium chloride to sodium carbonate using ammonia and carbon dioxide. 15. NaCl plus NH3 plus CO2 plus H2O NaCO3 plus NH4Cl. The sodium bicarbonate was then converted to sodium carbonate by heating it, releasing water and carbon dioxide.
2 na CO3 na 2 CO3 plus H2O plus CO2.
Meanwhile, the ammonia was regenerated from the ammonium chloride byproduct by treating it with the lime, calcium oxide, left over from carbon dioxide generation. 2NH4Cl plus CaO2 NH3 plus CaCl2 plus H2O. The Solvay process recycles its ammonia. It consumes only brine and limestone, and calcium chloride is its only waste product. The process is substantially more economical than the Leblanc process, which generates two waste products, calcium sulfide and hydrogen chloride. The Solvay process quickly came to dominate sodium carbonate production worldwide. By 1900, 90% of sodium carbonate was produced by the Solvay process, and the last Leblanc process plant closed in the early 1920s. 15. How's process? This process was developed by Chinese chemist Hao Debing in the 1930s. The earlier steam reforming byproduct carbon dioxide was pumped through a saturated solution of sodium chloride and ammonia to produce sodium bicarbonate. By these reactions, CH4 plus 2H2O CO2 plus 4H23H2 plus N2 2NH3 NH3 plus CO2 plus H2O NH4H CO3 NH4H CO3 plus NaCl NH4Cl plus NaCO3. The sodium bicarbonate was collected as a precipitate due to its low solubility and then heated up to approximately 80 degrees Celsius, 176 degrees Fahrenheit, or 95 degrees Celsius, 203 degrees Fahrenheit, to yield pure sodium carbonate similar to last step of the Solvay process. More sodium chloride is added to the remaining solution of ammonium and sodium chlorides. Also, more ammonia is pumped at 30-40 degrees Celsius to this solution. The solution temperature is then lowered to below 10 degrees Celsius. Solubility of ammonium chloride is higher than that of sodium chloride at 30 degrees Celsius and lower at 10 degrees Celsius due to this temperature dependent solubility difference and the common ion effect. Ammonium chloride is precipitated in a sodium chloride solution. The Chinese name of Hao's process, Lianzijianfa,
联合制碱法
means coupled manufacturing alkali method. Hao's process is coupled to the Haber process and offers better atom economy by eliminating the production of calcium chloride, since ammonia no longer needs to be regenerated. The byproduct ammonium chloride can be sold as a fertilizer. See also Natron residual sodium carbonate index. Sodium bicarbonate